So in this topic, we are understanding the prefixes used in naming binary compounds. These compounds will be molecular compounds. So let's look at our cheat sheet for naming molecular compounds. We're going to use Greek prefixes before the nonmetal name to indicate the number of atoms. So what are these Greek prefixes? Well, here they are. Here are the prefixes that correspond to particular numbers. So 1, the prefix to correspond with 1 is mono, di for 2, tri for 3, so on and so forth. So again, what we are asked to do is derive the chemical formula from the name of some binary molecular compounds. Let's look at the name of the first one, dichlorine monoxide. Well, we can easily derive the chemical formula from this name because we understand how Greek prefixes are used to name these binary compounds. If we take a double look at our guide, this tells us that we use the Greek prefix before the nonmetal name to indicate the number of atoms for the first element. The first element here for chlorine has the Greek prefix di in front of it. That tells me that I have 2 chlorine atoms. The second nonmetal name also uses the Greek prefix and the IDE suffix. So I see the IDE suffix here for oxygen, and I see mono in front. Now, the ending for mono, that O, was dropped because oxide starts with a vowel, so we dropped it to prevent doubling up. So this would read monoxide instead of monoxide. But nevertheless, we have oxygen. Mono is the prefix used, so this would be Cl2O. There's a 1 there, but we don't have to write that. Okay, so there is our chemical formula for dichlorine monoxide. I will note that there is an exception for when we're looking at the first nonmetal if we only have one of them. And so that's what we're going to see here. Carbon monoxide. Notice there is no prefix here. I thought that the guide said that we use Greek prefixes before not only the first, but the second nonmetal. Well, the exception is when the first nonmetal only has 1 atom, you omit mono as the prefix. You don't write monocarbon. You just write carbon. So that tells me that in this case, I have 1 carbon atom. I also have 1 oxygen atom because the prefix mono is used for oxygen. So that exception only applies to the first nonmetal atom in a binary molecular compound. If I have 1 nonmetal atom for the second nonmetal, I do still use the mono prefix. So mono would be the one with the exception applies to the first nonmetal. Here again, we have the same thing, carbon dioxide. Well, I see carbon. There's no prefix used there. It tells me that it must be 1, because if it were more than 1, if it were 2, 3, 4, 5, 6, 7, 8, 9, or 10, the prefix would be used. Di is the prefix for 2, and because I have oxide, the anion oxide, that means I have 2 oxygen atoms. Here we have carbon tetrachloride. Again, the prefix is not used in front of carbon. It must be 1. I must have 1 carbon atom in this molecule. Tetra is the prefix for 4. So I have 4 chlorines. Now, just as a side note, I do want to point out that these are molecular compounds. We don't have ionic compounds here. So these are not ions. Even though the second nonmetal has the IDE ending, it is not an ion. These are atoms covalently bonded together. We don't have ionic bonding here as primary bonds between these atoms, but covalent bonding. So just be sure that you understand that when we talk about how many of these atoms we have actual atoms, not ions. And these are molecules. So this chemical formula tells us exactly how many atoms of each element we have. Whereas when we were describing ionic compounds, we were using empirical formula, which gives us the simplest whole number ratio of cation to anion, but these are the exact number of atoms in each molecule of these substances.